So in this problem, we're going to find out the speed of the ball when you throw upward. So let's say you throw a ball here. You throw a ball with a certain speed. Let's call VI. It goes upward, comes to rest, or the speed at this point will be 0, and again comes downward. When you catch it, what is the speed of the ball? That's what you find out. Or in simple words, it is also asking at what speed did you throw the ball here. And just for your understanding, let me tell you one thing here. So on a path, on this path here, on this path, so the ball, let me redraw. The ball goes up and comes back. Okay. If I took at any level at this point or at this point, this is in the going upward motion and this is the downward motion. At each point on the same level, the speed of the ball is exactly the same. It doesn't matter where. So if I take it at this point, the speed of the ball is going, the ball will be exactly the same. At this point it is going upward and at this point it is going downward, but the speed will remain exactly the same. Okay, so that means if you throw a ball, let's say that 20 meters per second, it will come down to you exactly at 20 meters per second. If you throw any object, let's say 5 meters per second, it will come back to you exactly at 5 meters per second. But here is an assumption. We ignore, or we're simply ignoring the air resistance. If we include the air resistance, then the story will be different. Okay, but if we do not take the air resistance into account, the speed of the ball at which you throw will be exactly the same when you catch it. So let's write down all the information here. The given information is the height is 20 meters. So you throw a ball, it goes to a 20-meter high, and then it comes back to you. When it comes back to you, what is the speed of the ball? That's what you have to find out. So you can solve this problem in different ways, but here I'm going to solve from the conservation of energy point of view. So what does the conservation of energy mean? This means the total energy of the ball at any point will be exactly the same. The total energy. So at this point, when you throw a ball, this ball has a kinetic energy, and as it goes upward, all the kinetic energy is changing into the potential energy. When the ball comes to a complete stop, or when the ball is at the peak, or when the ball is at the top, all the energy of the ball is the potential energy. It does not have any kinetic energy at the peak. But the total energy that we call the mechanical energy remains exactly the same. So the total energy at any point of the ball will be exactly the same. And the total energy means potential energy plus kinetic energy. So the total energy at point A is exactly equal to total energy at point B. And the total energy is given by kinetic energy plus potential energy. Again, at this point B, kinetic energy plus potential energy. So let's write down what is the kinetic energy. You need the understanding the formula, or you must know the formula for the kinetic energy. So the kinetic energy formula is half mv squared. That's the formula for kinetic energy. And potential energy means here gravitational potential energy, which is mgh. So kinetic energy again at the point B is half mvb squared. Potential energy is mg times hb. Half, let's plug in here half mva squared as it is mgs. So our reference level is this height here. All the heights are measured with respect to this level here. So in this case the height is 0 because we have chosen this as a reference level. So that's 0. Half mvb squared. When the ball goes to the peak, at that point the speed of the ball will be 0. What we call a final speed is 0. So that is a speed is 0. mgh, and this height here from this reference level, this height is h. So that's the reason we have chosen H. This term is 0 because this is 0, this term is 0. So now I will have half mv square is equal to mgs. So this is kinetic energy and that's the potential energy, which makes complete sense because the kinetic energy at this point will be exactly equal to the potential energy at this point, which is the conservation of energy. So the mass and mass cancels out. So VA squared is simply equal to 2GH. So if I solve for VA, it will be square root of 2GH. So let's plug in the numbers. 2 G value, again just to make life easier or just to make calculation easier, we choose the value of G to be 10 meter per second square. Height is 20, so if you solve, you'll get 20 meter per second. That's the speed of the ball. That means this ball was projected upward at 20 meter per second. When it came back down, it also come back down to your hand with 20 meter per second. All right. So this is it from this video. And if you have any question, any confusion, write down in the comment section below. And do not forget to like, share, and subscribe the channel. Thank you.